Welcome, everyone. Happy Monday. For those of you who don't know, the American Council for an Energy Efficient Economy, we're a nonprofit research organization that develops policies to reduce energy waste and combat climate change. Our independent analysis advances investments, programs, and behaviors that use energy more effectively and help build an equitable, clean energy future. Oh. Just a few housekeeping announcements. We will be recording this webinar and it will be made available in a few business days. That will also include a list of all the registrants. To ask a question during the webinar, because after our panelists speak, we'll be having a Q&A section. Please submit it. Uh, um, I'm getting some people cannot hear me. All right, is anyone able to hear me?
Can hear you, but I have a
Oh,
panelist link.
okay, great. Um, Great. So as I said, please submit the questions via the Q&A button at the bottom of your screen, and we'll be monitoring the chat throughout the panelist discussion, and can address those questions at the end. You are also able to upvote them if you think they're of particular importance. That'll help us at the end as well. And you could also talk to each other via the chat if you want to directly respond to someone else's questions or comments. Next slide. So today we'll have four presenters. Rachel Allen, Transportation Director here at ACEEE, will begin with a discussion of our paper, as well as moderating the panel later on. And we have three great panelists today. Peg Hanna, Director of the Division of Climate Change Mitigation and Monitoring for the New Jersey Department of Environmental Protection. Bill Zobel, Senior Director of Hydrogen Supply and Infrastructure at Pilot Company. And Pedro Jardim, Principal Analyst at National Grid. Next slide. This is the agenda. We'll go through the welcome doing right now, and then Rachel will be presenting on our new paper, Pathways to Zero Emission Freight, Infrastructure Needs for Regional and Long-Haul Trucking. This will be followed by a moderated conversation with the three panelists I just mentioned, and following that will be an audience Q&A. But yeah, with that, I will pass it to Rachel.
Thanks, Peter. Welcome, everyone. So as Peter mentioned, I'm going to be going through some of the findings from our report released today, Pathways to Zero Emission Freight, Infrastructure Needs for Regional and Long-Haul Trucking. So first, we'll start with why do zero-emission freight corridors matter? Medium and heavy-duty vehicles have disproportionate environmental impact. They're also critical to the U.S. economy. And growing freight activity means that greenhouse gas emissions from these vehicles have grown 76% from 1990, more than 3 times the growth rate of on-road vehicle emissions overall. And even though they only represent 4 to 6% of the on-road fleet, they produce 23% of transportation greenhouse gas emissions and over half of on-road nitrogen oxide and PM 2.5 emissions. So failing to transition truck fleets means delaying health benefits from improved air quality, especially for those exposed to high levels of pollution from these vehicles. And the thing about regional and long-haul trucks is even though origins and destinations may vary, they do travel along predictable trunkline corridors and hubs. So infrastructure decisions for these trucks have an outsized influence on climate outcomes and community health. So our approach builds on the National Zero Emission Freight Corridor Strategy, which was released in 2024, which identified priority hubs and corridors to help guide public and private investment. And it took a technology neutral approach to building out this system and looked at building it out in 4 phases. But a lack of follow-on guidance and policy and funding uncertainty means that states, corridor coalitions, utilities, industry are increasingly leading on deployment. And so our analysis intends to build on this guidance and look at the state of technology of battery electric trucks and hydrogen fuel cell trucks while acknowledging that these technologies will continue to evolve. At the state and corridor and regional level, planning for and investing in both battery electric trucks and fuel cell electric trucks does create some risks around fragmentation, inefficient spending, or operational issues for regional and long-haul truck trips, which is the focus of our research. And the lack of a clear path forward could mean patchwork, underbuilt, or uncoordinated system. And the other thing about a multi-megawatt megawatt site means that it can require extensive distribution upgrades, and utilities are thinking about investments on a 10+ year cycle. And for hydrogen, the supply chains are nascent and require multi-year planning and permitting. So we're trying to help with a coordinated approach across stakeholders to not risk delaying infrastructure deployment or overspending public dollars. In our report, we compare technologies, battery electric trucks and hydrogen fuel cell trucks across a range of factors, including market readiness, range, refueling capacity, lifespan, total cost of ownership, and vehicle efficiency. And I'll go through a few of those comparisons here. Here's part of a summary graphic we produced. As you can see, the battery electric truck market is more mature than the fuel cell truck market in terms of trucks deployed. There's over 2,000 heavy-duty battery electric trucks and around 200 fuel cell trucks that have been deployed. There's over 60 models, battery electric medium heavy-duty truck models that are available for model year 2026, compared to 8 hydrogen fuel cell truck models, 2 of which are broadly commercially available. And though most of the medium heavy-duty battery electric trucks on the market today have between 100 and 300 miles of range, some recent entrants, models like the Windrose long-range truck and Tesla Semi, advertise ranges of 420 miles and 500 miles, respectively, which compares the Hyundai Accent, a fuel cell model, which has a 450-mile maximum advertised range. In terms of refueling times, for heavy-duty fuel cell trucks, that can typically range between 20 to 50 minutes, though with the usage of liquid hydrogen, that can potentially offer refueling times closer to 10 minutes. The Windrose long-range truck advertises a 38-minute recharge time using a 745 kilowatt charger. And there's a new technology, Megawatt Charging Systems, MCS, which has the potential to further reduce charging times to 30 minutes. There's a couple of these installed in California, and Tesla recently shared plans this year to deploy Tesla Semi megachargers in over 60 locations across the US, each providing at least 1 megawatt of power. So here's a map where we can see the 21 charging stations currently operating in the United States that can accommodate heavy-duty trucks. And there are an additional 100 stations for heavy-duty trucks being planned, including these 60 Tesla megacharger stations I mentioned before. And these are, all over the country, focused along key corridors. For hydrogen refueling infrastructure, there are 5 hydrogen refueling stations currently operating that can accommodate heavy-duty fuel cell trucks, and an additional 3 refueling stations are being planned. Another key factor for heavy-duty trucks is the curb weight. Trucks are prohibited from weighing more than 80,000 pounds on interstate highways, though battery electric trucks do get a federal 2,000-pound exemption on their maximum gross vehicle weight. So if you take out the curb weight and empty trailer weight from that maximum number, that's the truck's payload capacity, which is how much weight, the weight of the cargo that a truck can carry. And then for research, so right here we have modeled like the research of what these trucks could weigh, which is based on 2021 estimates. The colored bars here show that Class 8 fuel cell trucks could carry 4,000 pounds more than a Class 8 battery electric truck, according to these interviews, which is a modeled estimate, which looks at different components of the truck. But looking at actual existing truck models, the Class 8 fuel cell truck curb weights are more comparable to Class 8 battery electric truck curb weights for what's currently available on the market today. We also looked at energy efficiency across these 2 truck types. For battery electric trucks, 77% of the starting energy is used to move an electric truck. And that's primarily due to the fact that the state of the fuel is relatively unchanged from the start, and there's not that much energy loss in electricity transmission. Fuel cell trucks are currently associated with a higher rate of energy loss throughout the life cycle, primarily due to the energy loss during electrolysis, as well as during transportation, storage, and distribution of hydrogen. So Only 33% of the starting energy is used to move a fuel cell truck. And green hydrogen fuel, which is what's modeled here, is energy intensive to produce, and the conversion of electricity to hydrogen and then back to electricity results in some significant losses. So battery electric trucks, currently require less energy to operate. For comparison's sake, a diesel-powered semi-truck generally converts about 40 to 45% of its source energy into the operation of the truck. Now I'm going to move into our scenario design. We assessed the cost of station build-out for a nationwide network across 6 different scenarios that vary on 2 aspects. One is the mix between electric and hydrogen fuel cell trucks, and the second is the balance between public or semi-public and private recharging. So these scenarios apply to trucks that travel 200 miles or more a day, which are more likely to require corridor-based refueling and higher powered charging, which is the focus of our analysis. And then scenarios 1 through 3 have only battery electric trucks deployed with increasing levels of public charging. Scenarios 4 through 6 include hydrogen refueling stations as well. They assume 20% of heavy-duty trucks are using hydrogen fuel cell, and the other trucks are battery electric, in line with our expert consultation. Scenarios 4 and 5 mirror the earlier scenarios 1 and 2 with hydrogen added. And then scenario 6 assumes a fixed 200-mile spacing to estimate a lower bound hydrogen infrastructure need. And these are our findings in terms of what the total station investment cost would be through our study period 2025 to 2040. In scenarios 4 and 5, which do include those fuel cell vehicles, the cost of hydrogen refueling network is over $22 billion. The cost to build the charging stations is considerably less, ranging from $6 to $10 billion. And to give a sense of that scale, in 2021, total state spending on highways and roads was about $121 billion that year. So the cost risks are clear when you look at scenarios 2 and 5, compare those 2 scenarios, which are the same other than adding in the fuel cell vehicles. And in scenario 5 versus 2, the total cost is about 3 times greater, which is, that extra cost needed to build out a hydrogen refueling system. And we also have state-by-state investment costs in our results. I'm just going to show here the summary of, at a national level, what states need to invest. The states with the highest number of stations and highest cost per year are Indiana, Texas, California, and Illinois. And that's consistent with the fact that these states have significant freight activity and are really critical to the national freight network. And as you see over on the right with the bar graph, the number of stations increases throughout the period with significant growth in later years. This kind of drill down is focused on scenario 5. And the costs here at the bottom show the on-site station equipment and construction costs. And these station costs are based on real-world data collection and expert consultation, and then we validated those with external estimates. The grid upgrades required to supply the power to the charging stations are estimated to account for an additional 20 to 40% of overall project costs on average, though this share can really vary and is site dependent, depending on the station size and the local grid conditions. And then here's our station investment need for the hydrogen refueling stations, again, drilling down on that scenario 5. The state rankings are generally the same, though the annual costs are higher for the hydrogen infrastructure. And then for the infrastructure beyond the station development costs, according to estimates, may account for between 15 to 40% of overall costs, meaning that there's an additional 60 to 85% of total costs associated with the upstream production, transport, and distribution infrastructure, though these estimates are subject to greater uncertainty given the limited scale of hydrogen production, transport, and refueling networks today. Here's a map depicting key corridors. As you can see, they cross multiple state lines, requiring multi-state cooperation and investment. And then one key corridor, which we'll dig into a little bit more today, is I-10, which runs from east to west from California to Florida along the southernmost stretch of the U.S. In our analysis, we focus on the western portion of the corridor, which goes from California through Texas, given its importance as a trade route and its high freight volumes. Again, we looked at scenario 5, and we see that the total cost to build out the infrastructure for this segment of the corridor is $3 billion, with over 75% of the costs attributable to hydrogen stations. And then we calculated these costs using current freight traffic flow along this segment. And Texas has the largest share of investment, as you can see in the cumulative graph on the bottom right, due to its high freight volumes, as well as the fact that it contains over half of the mileage of this segment from California to Texas. So in terms of recommendations, in our report, we highlight and encourage corridor coalitions working to plan, facilitate, and fund the installation of zero-emission, medium, and heavy-duty infrastructure at the corridor level. We're going to hear from one such coalition in a bit during our panel conversation, looking at deploying charging hubs along I-95. Another key recommendation in our report is inventorying sites for development. One way to do this is to better leverage existing planning efforts at the state level, such as state freight plans, long-range transportation plans, port master plans, and corridor studies to help identify priority sites. States can also invest in preparation to make sites attractive for developers, including non-funded approaches like ensuring compatible zoning or creating expedited permitting pathways. Identifying sites for hub development can help facilitate the speed of development, and also the bonus of that could be working to help resolve truck parking issues, which is a major problem that is yet to be resolved and a major safety issue if there are more sites indicated through the analysis. Grid readiness. Charging hub companies indicate that most plan to develop hubs with initial capacities between 3 and 7 megawatts, with the ability to scale to 15 to 30 megawatts in the future. Grid capacity is a major constraint, so utility engagement, scalable site design, and alignment with proactive utility and regulatory planning are critical here. Shared hubs. Guidance released in August of last year explicitly permits using National Electric Vehicle Infrastructure, NEVI formula funding for medium and heavy duty charging infrastructure. And though currently threatened, that funding could go a long way. Public charging hubs give trucks of all ranges confidence that fast charging is available, and higher utilization at these shared hubs helps lower infrastructure costs. For hydrogen assets, we recommend using stage gates to prevent stranded assets. Hydrogen refueling infrastructure does carry a higher utilization and fuel supply risk because of its high cost and the complexity of hydrogen storage. So refueling stations for fuel cell trucks must be developed and refueled in close synchronization with fuel cell truck deployment. The technology and operational evidence in our paper points to battery electric trucks as the most infrastructure-ready option for regional and long-haul operations in the near term. And finally, consider community needs. Because pollution from medium and heavy-duty vehicles is concentrated around freight corridors and facilities, infrastructure planning should prioritize community health and protection and those communities with highest exposure to diesel pollution to help deliver near-term public health benefits. With that, I will conclude my presentation. We're going to move on to the panel conversation. I'll just mention that now that the report's published, our focus is really shifting to implementation. We want to work with state and coalition partners and build on our analysis, using our existing model and refining our findings so that they're useful in real-world contexts. And what that looks like in practice is supporting states as they consider their future needs, helping commissions think through proactive planning, and working with utilities to plan investments in corridor charging hubs. Thanks very much for listening, and we'll now transition to our panel. I'm going to stop sharing. All right, great. So welcome to our panelists. If you could all get your videos up, and we'll go through some moderated questions and then save some time at the end for audience Q&A. So for each of our panelists, can you introduce yourselves and tell us what role your organization is playing in building zero-emission freight corridors? And let's start with Bill.
Morning, everyone. Bill Sobel here with the pilot company, Pilot Flying J, for those who are familiar with the brand on the nation's highways. We operate the largest truck stop chain in North America, operate about 900 locations in both the US and Canada. We're trying to get ahead of the zero emission game, really all platform technologies. We're interested in trying out everything. We are the leader in providing on-road transportation fuel for the country. We provide about 15 to 20% of all the on-road transportation fuel for US heavy-duty trucking. So we're invested very heavily now, obviously, in the traditional diesel market. We're invested in biodiesel, renewable diesel, selling those commodities in states where it makes sense. We've recently embarked upon a B100 pilot in the Midwest. That's going very well. In this webinar, which focuses on zero emission fuels, we've got focus both on hydrogen and on battery electric trucks. I'll focus on hydrogen for my presentation. For those that watch the market closely, you may have seen our announcement with Tesla. We're putting in, I can't remember the exact number, 22 some odd stations, heavy duty refueling stations with Tesla's superchargers across the I-10 network and in California to help support the deployment of those trucks. On the hydrogen side, which is the area I manage for the company, we're evaluating a couple of hydrogen refueling stations in the state of California. We've also got some federal money to deploy some in Texas if we get that market where we need it. So we're very active in the space. And I'll stop there, Rachel.
Thanks, Bill. Pedro, will you go next?
Yeah, sure. Hey, thanks, Rachel. Thanks, everyone, for joining. I'm Pedro. I work for National Grid in our Clean Energy Development team. National Grid, for those that don't know, is an electric and gas utility in the Northeast. We're the electric utility for a large part of upstate New York and Massachusetts. And, I think what our interest in freight electrification is really we're kind of living through unprecedented times of load growth in the United States, be it building electrification, economic development with onshoring, data centers, and freight electrification. I mean, not to pat myself on the back too much, but National Grid, we're kind of on the vanguard of how utilities really think about how to better plan for this load growth to make sure that we are not the roadblock for states to achieve their goals, for the market to switch to zero emissions freight. Also doing that in a cost-effective way. We're in a kind of an affordability squeeze across the country, definitely in the Northeast. So make sure that we have the best information available to make the most informed investment decisions. So we're trying to pick winners of where freight will develop in the future. So
Thanks very much. And Peg.
Good morning, everyone. I'm a longtime NJDEP employee, going on 35 years, I guess, so over half of my life. The relevance for this panel for me here today is that we were fortunate to partner with Maryland, Connecticut, and Delaware and got awarded a $249 million grant from EPA under the Climate Pollution Reduction Grant Implementation Grant Program. So with that money, we plan to build publicly accessible freight truck charging infrastructure at about 24 sites throughout the 4 states. And those 24 sites will have about 450 ports, the way that we're estimating it right now. The money for each state was apportioned based on the amount of PM 2.5 emissions near the corridors. And I'm pleased to say that when we did the budget, we concluded that the majority of that grant money, the majority of the $249 million, will be used for the actual charging stations. Rachel gave a lot of good information about the different freight corridors and why they're important. This particular grant is going to be used for truck charging on and near the I-95 corridor. I think we all know that corridor has large amounts of population, ports, freight facilities. back a couple years ago, the feds did a national zero-emission freight corridor strategy, and this I-95 corridor was identified as a phase one priority. So I think that helped bolster our grant application. We chose to partner with Maryland, Delaware, and Connecticut because they all have been very active regionally and nationally in transportation electrification. They have rules and policies and financial incentives that we thought complemented this grant really well. Right now, we are planning to release the first grant solicitation. It'll be state specific, but I think New Jersey is going to be first out the gate. So releasing a grant solicitation probably in the May, June timeframe. Our total budget is about 84 million. So we'll be giving out about $84 million in grants for 9 publicly accessible charging depots in New Jersey. So yeah, why don't I stop there? There's, of course, a lot of other exciting pieces to our grant, but we'll stick to just that high-level overview for now.
Thanks very much for that, and to all the panelists for your intros. We'll start with some targeted questions. The first one is for Bill. Truck stops are emerging as key hubs for zero-emission freight infrastructure. How is Pilot deciding where and when to invest in hydrogen refueling and charging infrastructure at your sites? And Bill, I think you're muted.
There we go. Thank you. Good question. And I'll lead by saying that a lot has changed in the last year, right? There was just a strategy under the previous administration, and there is a strategy under the current administration. And our strategy hasn't changed that much, really. Pilot, we're looking to be a part of the energy transition, right? We effectively want to help manage and drive this energy future. The customers we're talking about, these long-haul heavy-duty customers, these are our customers, right? We don't want to lose these customers to other providers. We want to make sure that we have the fueling capabilities for whatever zero-emission technology is available to provide that to these operators. So the key for us, first of all, is just to kind of understand how these technologies work, what the economics are of the technology, how quickly these technologies are being adopted, which of our customers are interested in these technologies and where they operate. We're seeing a lot of interest in the California market right now, just based on the level of regulatory certainty that's in the state, right? The low carbon fuel program, some of the other programs that support trucking grants and so forth that help move that market forward. So then there's the commercial side of this, right? Obviously, we're a private company, we're a Berkshire Hathaway company, but we're looking to manage risk, right? So managing that risk as we move into a market that's relatively unknown that we see, has growth opportunity. We need to be very cautious about how we do that. So I will speak to the hydrogen side of this. I've got a counterpart that runs the EV side. I'll leave that to the other folks on the call today. But the way we evaluate on the hydrogen side, in terms of controlling that risk, is we're utilizing markets where there are publicly available incentives to help draw down some of that capital cost up front. And California just so happens to have other programs that help pay for the infrastructure, the capacity that you're putting in to help support the development of these new markets. They call it a capacity credit that's part of the low carbon fuel standard program. So that's another long range 10-year program that helps support the cost structure for putting in these refueling stations. Now, if we can get ahead of the fleets that are looking to put these trucks on the road, right, and pair up truck funding with station funding and bring those two together, that's how you sort of activate this market, I think. And the place hydrogen's going to get activated first is going to be California, and that's where we're focusing our efforts there.
Thanks very much for that answer. This one's for Pedro. When you led a corridor planning study, which National Grid did along a segment of I-95, what information was most valuable for forecasting future load, choosing locations, and determining grid investments? If you talk a little bit about that process, that'd be great.
Yeah, sure. So for those that don't know, National Grid, we led a study called the Northeast Freight Corridor Charging Plan. I'll drop a link in the chat as well. So that was a grant from the DOE for a 2-year study to really study freight demand and try to create a minimum viable network of freight electrification or freight charging from I-80, cutting Pennsylvania in half with the Port of New York and New Jersey as a hub, all the way to 95, the border of Maine and Canada. So it was around 3,000 miles of corridors, 9 states represented. And it was a multi-stakeholder effort. There were a lot of different data sources. Let's starting with kind of choosing locations. At first, we have a really super strong core team made up of National Lab, of NREL, now NLR, RMI, us, CalSTART, BeamReach, and NESCOM. We also had advisory committees representing the critical stakeholders that were part of the study, so representing industry, states, environmental justice, and utilities. So we gathered input mostly from states using their freight plans and from utilities looking at where our transmission and sub-transmission assets are in narrowing down what locations do we even want to study. We thought we were going to get around 80 sites from states. We ended up getting around 140 sites that RMI modeled all of that out, and we sent all that information out to states and utilities as well for their future planning. Then came the work of narrowing that down into these priority sites. And for that, we went out to the advisory committees for their inputs and what data is important to them. So states, for example, ranked each site based on how much truck parking is available. Is it a multi-value site, right? Is it close to a distribution center or another like pocket of load growth? So the investment that is made is used, even if truck charging doesn't pick up. And is it close to highways? Utilities were interested in load growth itself. I'll talk about how we did that load profiles and cost of investment. Environmental justice was interested in sites, with high particulate matters in the air. So kind of we had to put all of these different factors together, all these different inputs, and try to model out what are the 39 priority sites for emphasis in investment. A lot of science, a little bit of art too, in kind of choosing the sites to make sure we had appropriate coverage, north, south, east, west. They were spaced out within 100 miles of each other to come to this priority site. For the forecast itself, we relied on geotab information. So there's an input assumption there that truck behavior will be similar, that trucks will continue parking or fueling up where they fuel up now, because that's where we see the stops. So we modeled those stops into electrified stops, of course, with a gradient of pickup. So we can talk a little bit about there if people have questions. And then finally, for grid investments too, we went to the utilities and really asked them to model out if this load comes in by 2030, how much would it cost to solve for it? If it comes by 2050, how much it would cost for it? Trying to make the case if perhaps in some sites, kind of building it once, building it big, makes more sense, even though utilities and state regulators are not really incentivized to work that way. Maybe we build it just once, or maybe we do small incremental builds little by little. We got input from all the stakeholders. I think, those were the main kind of information that was valuable in order to create the study. But I think what was important as well is just how collaborative the effort was. I keep saying this, but we gave everyone homework on top of their actual work, and everyone turned it in complete and on time every single time. I think there was this thirst or this desire to collaborate across stakeholders on a study of this level, which was really great to see. And I hope we can give a continuation in the next couple of months. But
thanks very much for sharing more about that process. Great to hear the collaboration that went into that effort. The next question's for Peg. As we all know, freight corridors cross state lines. How did you get to a place where you were doing cross-state coordination and on infrastructure siting and investment? And how, I'll start there.
Okay. I have to say that I think I know this grant application and award would not have been possible if we didn't already have active and ongoing collaborative conversations with all of the states throughout the Northeast, as well as with California. And that is primarily thanks to the leadership of Georgetown Climate Center and NESCOM. They have been convening us for many, many years to coordinate on all things transportation. Started out with things like diesel retrofits, and now obviously we don't do too many diesel retrofits. It's more about electrification. So we were at a couple convenings with a bunch of states that Georgetown and NESCOM were leading, and we were talking about this grant idea. And I guess I just recognized the importance of just going all in and seeing what we could do as a region. It was the first time that we had done a multi-state application. And this was particularly interesting because we were working with DOTs from the other states as well as environmental agencies, and that was certainly new to me. But I have to say, I went into it eyes wide open and it was pleasantly surprised that the DOTs that we're working with in the other states had a tremendous amount of insight and information to bring to the table, and definitely gave me pause on a few things that I thought I understood. So I think that's sort of the long answer, but I think it's that ongoing commitment and relationship that we all had that got us to this place where we are now doing a multi-state project for truck charging.
Great. I think all of you have touched on, coordination across your different answers, and the role of different players in the ecosystem. So just to maybe like put a finer point on it, would like to hear kind of what you'd wish from a specific partner. So we'll start with Pedro from the utility side. What would you wish to have from state partners to plan effectively, or what maybe did you have when you were doing your study?
Yeah, I think something we had was a unified one state voice. We had representatives from many different agencies in each state, right? So just thinking about New York, we had someone from the DOT on it, someone from NYSERDA, and someone from New York's DEC, Environmental Conservation Agency as well. Other states also had some representatives from, chief of staff to the governor down to other specific agencies. And just having that amount of intrastate coordination is important to us so that when we can talk to the DOT and say, hey, your freight plan, isn't NYSERDA aware, right? It's the first time that really we have to think about transportation, and some transportation agencies have to think about electrical infrastructure. So making sure that there's a good level of coordination internally is important to us. And, I'm just proactive planning proceeding is top of mind for now for me. That's a proceeding opened up here in New York where we're allowed to propose grid investments ahead of customer needs, which really is not the norm across the United States for utilities. So having a state agency come to us and say, hey, location X is central for our freight plan, right? We are planning for incentives to be here, to install chargers, to attract investment. So please kind of propose this investment, or let's work together to right size this investment. I think that lends more credibility to our investments, both internally and externally as well. As we're talking about affordability, and make sure that the ratepayers are also not saddled with extra costs that are necessary. So making sure there's a clear two-way street in terms of prioritizing sites and information sharing, I think is key to us.
Great. Thanks for sharing that. Peg, from a state perspective, what do you need from utilities to move corridor projects forward? How is that coordination going for the projects you mentioned?
Yeah, so I think the biggest thing for us is to make sure that the utilities are aware that we're going to have grantees coming in and wanting to build these huge sites, at least 1 megawatt, likely 2 or 3 megawatts. So making sure that they are aware that potential site developers are going to be coming to them and asking for a load analysis. In New Jersey, we've been having monthly meetings with all of our utilities and our PUC for a couple years now, and those meetings are meant to talk about upcoming policies as well as grant opportunities. It also helps them to do a little bit of upfront planning. If they know what's coming, they're better able to prepare. For the NEVI funded projects, I know our utilities did a red light, green light process, which is basically a streamlined, just right up front, quick and dirty analysis to say to a site developer, yes, we think this proposed site has sufficient capacity, don't need to do a full-fledged load analysis, probably no exorbitant cost, go forward. Or red light, meaning not a lot of capacity there, you're going to be looking at increased costs for interconnections and supply. So thinking about those kinds of conversations and how we translate or bring those over to the medium and heavy duty world so that developers and utilities are both prepared for those conversations.
Great. Thanks very much. And Bill, I guess what is Pilot hoping for from partners, state partners, when it comes to making decisions and investing in zero emission infrastructure?
Well, we're at this point in the market cycle, right? I think one of the points I'm trying to make in the Q&A, I see a lot of questions on, why are we doing this now? You compare the two technologies. To compare the two technologies head to head today is really an unfair comparison, right? They're in different levels of maturity, and I think your report does a good job of sort of pointing that out, right? It's like comparing the maturity of 11-year-old to the maturity of a 21-year-old. Hydrogen's about 10 years behind. Got a lot to learn, got a lot to apply to the market to make it more efficient and to make it more commercially viable for moving forward. What is helping to do that today in select markets like California is regulatory certainty. So from the partners we have in the public space, we require regulatory certainty over a long term to ensure that we can de-risk these investments and get a return on that investment over the time frame that we've allotted for it. So for us, it's about just making sure that the programs we put in place stay in place, right? So that once we invest in the asset, we continue to operate that asset under that regulatory regimen. This back and forth between administrations and back and forth between governors and different state priorities, that makes it very difficult to invest in any technology, whether it's battery, electric, or hydrogen over the long term.
Great. Thanks very much for that answer. Now this one's open to anyone. And it kind of builds off of some of the other comments people are making, but Bill mentioned regulatory certainty. Where is public leadership most critical to getting these corridors built? And where should the private sector lead?
I can start with a recommendation on where I think some government leadership or coordination is needed, and I think that's for the municipal and county government that are going to have to do the permitting and zoning and planning for these sites. I think making sure that those decision makers at the county and local government level are educated on what the operational characteristics of these big EV depots look like. And also for New Jersey, if we have something that's a permanent accessory use, so for example, you're adding a charging station to a gas station or to a warehouse, that's pretty simple. We have a streamlined permitting process for that. But if you're putting in a brand new truck depot as a primary use, and that use isn't currently allowed, now you're talking about something that needs to go through a zoning board, planning board, et cetera. So making sure that we are connecting the dots there and connecting these developers of the sites with the most important people at the municipal and county level that are going to be reviewing those zoning applications or looking at variances, looking at setbacks to make sure that everybody understands the project early and often, as they say. So I think leadership to make sure that those conversations are and policy decisions are happening at the local and county government level.
Great. Thanks for that. Anyone else want to weigh in?
Yeah, I'll say, I mean, for us, just clarity on policy goals is the most important thing, be it at the state level or at the federal level. Changes to policy that are significant kind of alter our investment timelines. It alters the way that our planners think about our models and when we're going to be constrained in certain areas. So it really puts us back in the drawing board, and that takes away the level of certainty necessary to develop projects and propose projects for approval. I know it's crazy time, so it's easier said than done. That yeah, just stick to a target. But that really has deep impacts in our planning. It sets us back a fair amount. For the private sector, I mean, I think just really shout from the rooftops, right? The actual economic benefit of zero freight. The Tesla announcement from this week of the semis rolling out at some point this year, I think is exciting. But the more we can actually make the TCO argument that it's not just an environmental question, but an economic question for the benefits of switching, the better will be.
Great. Bill, anything you want to add to this one?
Oh, I mean, I think I touched on it, kind of got it started, but I would echo something that Pedro said earlier about the affordability crisis, right? The U.S. generally nationwide is in what we're calling an affordability crisis, and elected officials have a unique ability to pounce on crises like that and use them for various purposes. So I think we just need to ensure as investors in this marketplace, right, that this affordability issue that we have today doesn't impact our ability to continue down this pathway. I think it may. We'll have to all keep an eye on that. But the ability, I think, of us as an industry to try and retain the certainty that we have in the regulatory market today is going to be important.
Great, thanks for that. All right, well, I have one more question for all the panelists. I want to put in a plug for anyone who's listening in to put a question into the Q&A. We'll get into those in a little bit. So let's look into the future a little bit. If we all reconvene in 5 years, what would success look like for zero emission freight corridors in the US? What do we want to achieve 5 years from now?
So from a numbers standpoint, when we applied for this grant, we assumed 30% utilization of our sites by 2035. So I think I think we probably should have aimed for 50%, except we didn't want to be held to that. So I think for today, we should aim for 50%. And if we get 35% by 2035, which is a little more than 5 years, I'd consider that a success.
I think for us, oh, go ahead, Pedro.
No, go ahead.
I think for us, it's going to be, we 5 years from now, we expect to have a much better understanding of the economics around both these technologies and allow the customers that want to move into this space to evaluate these technologies on a real-time basis, right, with their operations in a variety of different areas throughout the country. And that includes both our battery electric side and our hydrogen side. I would like to see a couple more hydrogen heavy-duty truck manufacturers enter the U.S. market, right? There are Volvo and Daimler are both active in Europe. They're not active here. I expect they'll bring those technologies here by the 2030 timeframe, something like that. Just to touch on some things that they're doing that's going to, I think, just be a sea change in the industry is they're changing the way they're storing the fuel on board the tractor. So they're looking at liquid on board to compete more directly with diesel than storing it as a high-pressure gas on board the vehicle. If you do that, the weight of the tractor comes down considerably, the range of the tractor goes up considerably, the cost of the tractor goes down considerably, and the cost of the infrastructure goes down a tremendous amount as well because you don't have to compress that fuel. So I think, as I mentioned, in the maturity curve of this industry, we're at the very nascent point of the industry, and you're going to see a lot of innovation over the course of the next 5 years. That's what I would be hoping to see, is that take place and to see more entrance into the market.
I mean, I think they covered it pretty well, but just again, we move away from an environmental question. I believe it's an environmental question, but into an economic question. So that's not a crutch anymore that people can just, shove this off to the side, but this actually makes economic sense for freights of all shapes and sizes. That the federal government kind of picks back up the work that you guys are taking on from the joint office used to do as well. And at the state level, that we keep maturing freight planning and match kind of with utilities as much as we can as we think about investments of these big hubs.
Great. Thanks, panelists, for all those comments. We'll move on to the Q&A segment. We got some questions in here, which I'll go through. We'll start with a question from a freight planner from the Minnesota Department of Transportation, who asks, in building out public truck stops for either hydrogen fueling or battery electric charging, as Pilot is doing and New Jersey and other Northeast states are, how do you balance concerns from private industry about operations and duty cycles, such as ensuring trucks can get access to hydrogen or charge when they need it? How do you work with or will work with stakeholders to ensure they know what is available and how it meets their operational needs? So any comments on how to address concerns from private industry about access to infrastructure? And I can also answer this from the perspective of our report too, but wanted to see first if any of the panelists have thoughts.
Why don't I try to come at this from the freight planner's perspective at DOT, Lydia? I think what when you're at that level and you're looking at developing out a new infrastructure for heavy duty trucking, right? Whether it's battery or whether it's hydrogen. In the case of hydrogen, you need to make sure you've got access to the entire supply chain, right? There has to be, obviously, starting from the back end, you have to make sure there's trucks, there has to be refueling centers, a distribution network, and then you have to have supply. That's one of the things that's unique about the hydrogen market as compared to EV. You can't just plug into the grid and get your power or get your hydrogen, right? Somebody has to produce that fuel, and you have to ship that fuel to the market that it's going to be operated in. If you're going to do that for hydrogen, I don't know how much supply is available in the upper Midwest from Minnesota, but that's something that you could certainly do some research into and find out. But there are ways to produce hydrogen at small scale that can get some stations started, even on-site production, to get that market moving in the right direction. But from a planner's perspective, I would start with regional hubs, right? Small circles where you've got a production facility that can support a freight market in a certain area. And then as you build that out and get more redundancy in supply and improve the resiliency of that supply chain, you start to build that out from there and connect down these interstates in these various hubs, Rachel, that I think your report touches on. So the way I see the market developing is it's going to start in very localized regional areas, then it's going to grow to a broader subset of that regional area, and then use the interstates across the U.S. to develop a national network. So for statewide planners, it's okay, let's start small with hydrogen. Let's get this thing off the ground. Let's get some fleets that are going to try this with maybe some localized production and then move forward from there.
Great.
If I can add to that, I had two other thoughts, sort of coming at it from a different perspective. We did a request for information prior to drafting this grant solicitation, and the request for information was to make sure that we were getting it right, making sure that the specs that we were going to issue for these sites was on target, making sure that our geographical criteria were on target, et cetera. And we compiled all of the results from our RFI with the results from other RFIs had been issued, and actually published a compendium, which I'm happy to share with Rachel, and she could send it out afterwards. So making sure that we were reading the market and the potential landscape correctly. But then also, I think in terms of the portion of your question that deals with making sure we're accommodating the freight operator's need or the fleet's needs, we are planning to allow a couple different operating models for these sites. So everything ranging from first come, first serve to an appointment-based model to a subscription-based model. And all of those are considered publicly accessible in some way, shape, or form. So they'll comply with our grant, but they also, I think, help to address some of the predictability needs that our fleets are going to want to have before they commit to this.
Great. Thanks for that. So let's see another question we've gotten. This one is about the report itself. The question is, how much did green hydrogen contribute to the much higher cost for the hydrogen scenarios? Or were dedicated hydrogen pipelines infrastructure the primary cost driver? I'll just say that our analysis really focused on station development without upstream costs. So we didn't look at production costs in our assessment for either technology. And so the green hydrogen production costs were not part of our total costs. That obviously is part of the whole value chain, but it's not something that we include in our estimates because there's a lot of uncertainty about that. We did talk about some other studies of that and have some, of those findings in our report, but it's not part of our overall numbers for our scenarios. Okay, and then let's see what else we have here. What lessons from the currently installed in operation chargers and H2 refueling stations have been learned and used, incorporated in the report? We looked at costs across a lot of different sites and used that in our cost estimates. I think that when it comes to actual, installing stations, refueling stations, maybe it would be good to hear from our panelists on anything learned on the ground. Bill, if you want to speak to the hydrogen refueling stations question of it, what you've learned.
Yeah, that's a really good example because we've come a long way in the last couple of years. The network in California that had traditionally supported the light duty market, that was kicked off in 2019, suffered with low reliability, very poor reliability. And just to sum it up, so we're running short on time. The reliability of the network has gone from somewhere around 60% to above 85%. So we've done a lot to help improve the reliability of the systems. The second piece is the supply side. The supply situation for hydrogen, the supply market, is still very fragile. I think the industry understands that. We've made some strides and try to move the market more towards liquid supply, which has a much more robust and reliable supply chain, if you will, versus gaseous supply. So we've seen that move also take place, and that has added to the resiliency of the network, but we're still not where we need to be. There's still a long way to go there to help bring those stations up to what would be comparable for a diesel station, right? Where you pull into a diesel pump, the diesel's going to be there every time. You don't have to worry about supply. And it's very reliable and very convenient. So I think both markets, EV and hydrogen, still have a ways to go to accomplish that.
Anyone else want to speak to deployed stations? Any lessons learned?
I don't know if lessons learned, but I think just some anecdotal evidence is that the sites where we've modeled up future load tend to line up with sites that we're seeing already the higher utilization at travel plazas. So it lends credence that where trucks are stopping now, it's maybe where they'll stop in the future a little bit. These are obviously the biggest sites with more parking, more facilities. So those are lining up a little bit. So that's good to see.
Peter, I'm glad you made that point. A lot of the planners are looking at, and a lot of the grants that have come out from various agencies have tried to find the right distance to put these stations apart, right? Not sure we really need to do that. The refueling centers are there, right? And they serve the fleets today. So to your point, I think focusing on those refueling centers that are available today will serve the market tomorrow as well with the new fuel.
Great. Let's see. I think we have time maybe for one or two more questions. We'll see how long this one takes. We got a question asking, from a policy perspective, is it an issue to invest in hydrogen for freight since end use is less energy efficient than electricity? Is there a conflict with green hydrogen that could be used for other purposes, stationary storage, industrial uses? I'll just speak to this to say that, there is other market end users for hydrogen. We didn't look at that in our report, but would love to hear from maybe Bill on this one if you have any thoughts.
Let me start with the efficiency question because I get that a lot, right? It's like, and it's obvious, right? The end use of hydrogen is less efficient than the end use of electricity. But that's really not what we should be focused on. I mean, if the world was all about efficiency, we'd all ride bicycles. Fact is, we don't, right? Bicycles don't serve all of our needs. So when you're a freight operator, what you're concerned with is your total cost of ownership of your operation, right? And how does that line up to what you're using today, the traditional fuel? So efficiency aside, right? What's a total cost of ownership of hydrogen versus the total cost of ownership of a heavy duty EV operation for me? That's how a freight operator is going to evaluate that going forward. They could care less about what the efficiency of the tractor is. In terms of other uses, I think, Rachel, that gets to the supply side question, right, of the hydrogen market, and where that could go. If the market is going to move to a liquid-based supply system, which I think long-term would be the best move for the overall market, but will take some time, you've got to anchor large off-takers like data centers, refineries, chemical plants, other power plants, high-end uses of hydrogen to help support that build-out. It's going to be difficult to do that with transportation unless you can aggregate a large amount of users in a single area. And at the outset of the market, that's going to be tough to do. So while your report doesn't touch on it, I think it's important that everyone understand there are lots of other uses for hydrogen out there that will help support the growth of the market.
Great, thanks very much. We are at time. Please join me in thanking you can't really clap because everyone's muted, but thank you so much to our panelists for their wonderful comments and sharing your experience. Really appreciate everyone's insights. For the questions we didn't get to answer, we'll try to follow up with people afterwards. We'll also be following up with the recording, the slides after the meeting for all the registrants. Thanks so much for joining us today.